let's use that formula. So here we have an example. You can pause and write it. You have 13 kumquats. 85% of kumquats in general are fresh, we're saying. What is the probability that exactly 10 of the kumquats are fresh? So the way we're always going to do this is we're going to write down the givens. So we're going to say, what are we defining as a success? What is N? What is P? What is Q? And what is X? Okay, so what are we going to call a success here? We're going to say that a success is and the success is for one trial. So the success is not going to be that 10 are fresh. That's going to be something else. That's going to be the number of successes. Success is for one trial, and we're going to say that a success is that we take a kumquat and it is fresh. N is the number of trials. So we have 13 trials. P is the probability of success. Success is that they're fresh, so that's going to be 0.85. Q is going to be the probability of failure, which in this case would be 0.15. X is the number of successes. We want 10 are fresh. We defined fresh as successful, so we want 10 successes. So the probability that X equals 10 is N choose X, P to the X, Q to the N minus X, which is 13 choose 10 times 0.85 to the 10 and 0.15 to the 13 minus 10, or 3. So we can plug that in, and we get 13 choose 10 times 0.85 to the 10 times 0.15 to the 3. And I got a lot of zeros. 19.00%. So there you go. That's the probability in the situation that exactly 10 kumquats are fresh. Now, success and failure doesn't mean much. You can actually define it in multiple ways. I'll show you what I mean by that. So here's example number 5. You have a probability of 0.2 of missing a free throw. What's the probability that you will miss exactly 3 out of 11 throws? Okay. So we'll write down our things. So we'll say that success is miss a free throw. I mean, it doesn't have to be N, P, Q, X. So success is not really a moral judgment. It's just what we're naming one of the two outcomes. So we're going to miss a free throw. And we have 11 trials. The probability of success is going to be 0.2. Probability of failure would be 0.8. And we want to miss exactly 3 of them. So X would be 3. So if we go through that, we will get that the probability that X equals 3 is 11 choose 3 times 0.2 to the 3 times 0.2 to the times 0.8 to the 11 minus 3, which is 11 choose 3 times 0.2 to the 3 times 0.8 to the 8. And I got 22.15%. And that would be the answer. Now I squished it all over here because I want to do something actually. What I want to do, let's kind of put a dashed line on the middle here. I want to change my definition of success. So let's keep it more in line with reality. So success is going to be that you make the free throw. So you sink the basket. I don't know what the right terminology is. Make. I keep on forgetting I switch colors for that. Make the free throw. So let's see what that does to our variables, our N, P, Q, X. So number of trials, still 11 trials. Now our probability of success, since we said that success now is making the free throw, not missing it, the probability is now going to change. The probability of being successful now is going to be 0.8, and the probability of failure is going to be 0.2. Also, for our X here, we want to miss exactly 3 out of 11. That means we want to sink 8 out of the 11. So the number of successes we would want in this case would be 8. So changing success, what it does is it switches the P's and the Q's, and it also mucks around a little bit with the X's. That's going to be weird because we're going to get a different answer, maybe, right? So the probability that X equals 8, this pen is way too thick for this, is going to be 11 choose 8 times 0.8 to the 8 times 0.2 to the 11 minus 8, which is, if we plug it in, 11 choose 8 times 0.8 to the 8 times 0.2 to 3. And, what do you know? It turns out to be exactly the same. So the takeaway from this is it doesn't really matter what you define as success. You could call either of the two outcomes success as long as your N, P, Q, and X are consistent with your definition.